Hello everyone, in this video we're going to review the topic 1.12 to 1.14 of the Unit 1 Transformation and Modeling Functions. Alright, question number 1. Let G be a function that is a transformation of the function f such that g of s equals 3 times f of s minus 2. Describe the transformation of the function f that results with the function g. Alright, so we know that the transformation form is going to be a times f of b times s minus h plus k. And then the order of transformation should be b, h, a, k. The trick for you to memorize this one is Brandon, hugs, and kisses, right? Now, A tells us that vertical dilation. B, horizontal dilation. H, horizontal translation. If H greater than 0, it translates to the right. If H less than 0 is translated to the left, is the vertical translation. If K greater than 0, it translates up. If K less than 0, it translates down, right? Now, anything related to S value, think opposite, right? Alright, now take a look at this one right here. Alright, so we see that H equal to, which is greater than 0, right? And A equals 3, right? Since H equals 2, it's going to be a horizontal translation 2 units to the right, right? And A equals 3 is going to be vertical dilation by a factor of 3, right? Now let's move on to question number 2. Let K be a function that is a transformation of the function h such that k of s equals h of 4s minus 1. Describe the transformation. Alright, so we see that b equals 4, right? And k equals negative 1, right? So, there is a horizontal dilation by a factor of 1/4, right? And vertical translation down 1 unit, right? Keep in mind anything related to S value, think opposite, right? So right here, you see 4 right here, it's going to be horizontal dilation by a factor of 1/4, right? Now let's move on to question 3. Let R be a function that is a transformation of the function P such that R of S equals 5P S over 2 plus 3. Alright, now we need to rewrite this function. It will be R S equals 5P of 1/2 times S plus 3, right? So we see that A equals 5, right? B equals 1/2, right? And K equals 3, right? So there is a vertical dilation by a factor of 5, horizontal dilation by a factor of 2, and vertical translation of 3 units, right? Now let's move on to question number 4. Now we observe that A equals negative 2, right? So which means you have the negative side in front of A, which is there is a reflection over the x-axis, so keep that in mind. Now you see negative h right here, which is b equals negative 1, right? No h and no k, right? So in this situation, we have the reflection over the y-axis, right? Because b equals negative 1. And vertical dilation by a factor of 2, and then reflect over the x-axis, right? Now let's move on to number 5 and number 6. The table below gives values for a function f at selected values of s. Use the table to answer question 5 and 6. Alright, so g of s equals f of 3s plus 2. Now g of 3 is going to be f of 3 times 3 plus 2, right? So it could be f of 9 plus 2, right? So f of 9 is going to be negative 6, right? So negative 6 plus 2 is going to be negative 4, right? Now g of negative 1 is going to be f of 3 times negative 1, right? Plus 2. So it's going to be f of negative 3 plus 2, right? And then it's going to be f of negative 3 is going to be negative 1 right here. So negative 1 plus 2 is going to be 1, right? Now, question 6. h of 3 equals negative 2 f of 3 plus 3, right? So it's going to be negative 2 f of 6, right? F of 6 equals 5, so it could be negative 2 times 5 equals negative 10, right? Now question B, h of 0 equals negative 2 f of 0 plus 3. And then it's going to be negative 2 f of 3, right? Now f of 3 equals negative 2 right here. So negative 2 times negative 2 is going to be 4, right? Now let's move on to question number 7. The function k is constructed by applying three transformations to the graph of h in this order. First, horizontal dilation by a factor of 1/2, right? So when we talk about the horizontal dilation, which means we talk about the value of b, right? Because b related to s, right? So when it comes to any variable related to s, think opposite, right? It's going to be b equals 2, right? Vertical dilation by a factor of 3, which is a equals 3, right? Now, vertical translation. In the formula, I use k, right? Now, in this formula, they're going to use c, right? So you just let c equals negative 5 right here, right? Now, let's move on to question number 8. The graph of f is given in the x and y coordinate right here, within the interval negative 4 to 4, right? The graph of g is f of x plus 1 minus 2. Alright, so observe that h equals negative 1, right? Because we have the formula a times f of b times s minus h plus k, right? So you just match them up. Negative h equals 1. So then h equals negative 1, right? K equals negative 2, right? So anything related to s is going to be opposite, so keep that in mind. Now h equals negative 1 is translated to the left 1 unit, right? And k equals negative 2 is going to be translated down 2 units, right? So you have a point right here, go to the left 1, go down 2. It's going to be right here. This point, left 1, down 2, is going to be right here. This guy, left 1, down 2, is going to be right here. Left 1, down 2 is going to be right here. Now you just connect this point and you get the graph. Alright. Now let's move on to question number 9. The function f is given on the x and y coordinate plane right here, within the interval negative 3 to 4, right? The graph of h is given by 2 times f of negative s, right? So in this situation, a equals 2, which means there is a vertical dilation by a factor of 2, right? And then you see b equals negative 1, which is there is a reflection over the y-axis, right? So by the order of transformation, we need to do reflection first, right? So I have a point right here. The distance from here to here is going to be 4, right? Now, I need to reflect this one over the y-axis, so 4 to the left right here, right? This one right here, 1, right? So it could be right here. Now this guy right here, 1, right? So it could be right here. And this one, 3, right? So it could be right here. Now I just connect this point, right? Now since a equals 2, which means you need to multiply the y values by 2. You need to keep the s value the same, right? Now you look at this point right here. S value is 1, Y value is 3. So you just multiply 3 by 2. It's going to be 6. And you keep the same S value, right? So the new point should be right here. Right? This guy same thing. 3, 3. You multiply 2 by 3, right? So it can be right here. Now, this point right here, y equals negative 2, right? You multiply by 2, it's going to be negative 4, so it can be right here. S still negative 1, right? So it's going to be right here. And this one right here, S equals negative 4, Y equals 1 right here, right? So you multiply 1 by 2, it's going to be right here, 2, right? So the point should be right here, right? Now you just connect this point. Now let's move on to question number 10. The graph of f is given in the xy coordinate plane right here, within the interval negative 3 to 4. Now we need to sketch the graph of k, given by negative 2 times f of x plus 3 plus 1, right? So look at this one, we see a equals negative 2, which means there is a vertical dilation by a factor of 2. Right, and reflect over the x-axis, right? Now, h equals negative 3, which means there is a translation 3 units to the left, right? And k equals 1, which is there is a vertical translation up 1 unit, right? Now, we need to reflect this one over the x-axis first. Alright, so it's gonna be like this. Now, next one, we're gonna dilate this one vertically. Now, next one, we're gonna dilate this one vertically by a factor of 2, which means we're gonna keep the s value and we're gonna multiply the y value by 2, right? So we have this one. Alright, so we just finished reflection and dilation, right? Now, we're gonna move to the left 3 units and move up 1 unit, right? So the final answer must be this. Alright, so the final one must be the pink one. Now let's move on to question number 11. The domain of the function h is negative 5 to 10, and the range is going to be negative 4 to 2. Now find the domain and range of the function g, where g of s equals h of s minus 5 plus 7. Alright, so let's domain of the function g should be hg. The range of the function g is yg. Alright. Now we look at this one, we see that h equals 5, right? K equals 7, right? So basically, I have s, h. You look at this one right here, anything related to s value, thing opposite, right? So this is subtract 5, which means you need to add 5 equals hg, right? Now, this one right here is the vertical shape, right? So you don't need to change anything, right? So we have yh plus 7 equals yg. Alright, keep in mind you only do the opposite thing when it's related to s value, right? Now the domain of the function h is given right here, right? So I just substitute negative 5 and 10 for h of h right here. So I have hg is going to be from negative 5, substitute over here, negative 5 plus 5, it could be 0. 10, substitute over here, it's going to be 15, right? Now the range, negative 4, substitute over here, it's going to be 3, right? 2, substitute over here, it's going to be 9, right? Now let's move on to question number 12. The domain of the function k is negative 4 to 8, and The range is going to be -7 to 3. Find the domain and the range of the function R, where R of S equals 2 times K S over 3 plus 1, right? So I just rewrite this one a little bit. This could be 2 K of 1/3 S plus 1, right? So I know that A equals 2, right? B equals 1/3, right? Now I just undo this one to get the function R, right? Does it mean I'm going to do the vertical dilation by a factor of 2 on the function K to get the function R, right? And I'm going to do the horizontal dilation by a factor of 3 on the function K to get the function R, right? Now, as I told you before, anything related to S value, thing, opposite. Alright, so this is 1/3, right? It's going to be 3, right? So I have 3 S K. It's going to be S R, right? And we have the vertical dilation right here and vertical translation right here, right? So it's going to be 2YK plus 1 equals YR, right? Now, SK is going to be right here. Alright, so S equals -4, substitute over here. I have -12. S equals 8, I substitute over here. I have 24. So the domain of the function R is -12, 24, right? Now, for the range, Y equals -7 right here, substitute over here. So I have -7 times 2 is going to be -14 plus 1, -13, right? 3, substitute over here, it's going to be 2 times 3, it's going to be 6 plus 1, it's going to be 7, right? Now let's move on to question number 13. The domain of the function f is given from -10 to 0. And the range is going to be from -8 to 6. Now we need to find the domain and the range of the function p given by -3 f of 2s, right? So we have a equals -3, right? And b equals 2, right? Now we're going to deal with the domain first, right? The domain, we need to use the b value, right? Now anything related to S value, thing opposite, right? So you have b equal 2, which means 1/2, right? 1/2 of what? S right here of function f equals S of function p, right? So we have the domain. Now, the domain of the function f is going to be -10 to 0. You substitute -10 for S of f right here. Alright, so it's going to be -5. And 0 substitute over here, it's going to be 0. Alright, now the range is going to be -3 of y of f, right? This one right here equals yp. So the range is going to be right here -8 and 6, right? So -8 substitute over here, it's going to be -3 times -8. It's going to be 24. Now 6 substitute over here, it's going to be -18, right? So we need to rearrange this one, right? So it turns out to be -18, 24. Now let's move on to question number 14. The table above provides data for 7 order pairs S and Y. Which function type best models the data in the table? Linear, quadratic, or cubic? Alright, so we look at this one, we see that this guy and this guy, if we add them up, we divide by 2, it's going to be roughly number 5 right here, right? This guy and this guy, add them up, divide by 2, roughly 5. This guy and this guy, add them up, divide by 2, it's going to be this one. So this one is the axis of symmetry. So it should be quadratic function. Alright. So you know that quadratic function is going to be something like this, right? And the axis of symmetry is the one that split the quadratic function in half, right? This one is the vertex, so the vertex right here. Alright, axis of symmetry s equals 5, right? For the left branch, the y values going down, log 40, 11, 3, right? The right branch is going up, log 3.7, 11.25, and 39.5, right? Now let's move on to question B. Write the equation of the regression model for the data in the table. Alright, so we're going to use the calculator because this question requires us to use the calculator, right? So I'm going to use the TI-Nspire calculator first, right? So this is the home screen of the TI-Nspire calculator. Now you need to hit spreadsheet right here, this table right here. Alright, now you need to name the column, right? I name as, for the second column right here, I name Y. Now I need to input the values for the table, right? Alright, now after you input the values for the table, you're gonna move your cursor to the right of these two columns right here. So it should be right here. Alright, now you're gonna hit menu number 4 right here, start. Number 1, start calculation. And then you're gonna find the quadratic regression, should be number 6 right here. Alright, now the first one right here, you need to put S. Now the second one right here, you need to put Y, right? Now this is F1, which means our equation as F1, right? Now you need to hit OK. So your quadratic equation should be, let's move on to question C. What is the residual for the point whose x coordinate is 6.1? Alright, so x coordinate 6.1, which means this one right here. Alright, y equals 3.7, right? Now we have the formula. Residual is to be actual value subtract the predicted value. Alright, actual value is the one given in the table. Predicted values is the one we need to use the formula right here to calculate, right? If the residual less than 0, the model overestimated the actual value, which means the predicted values bigger than the actual value, right? Now, if residual greater than 0, the model underestimated the actual value, which means the actual values is bigger than the predicted value, right? Now we're going to use the calculator to calculate this one, right? Now we need to use this model to predict the values of y when x equals 6.1, right? So previously we have equation right here and we save our equation under F1, right? Now we just hit Control I and add calculator right here and we hit F1. Alright, hit parentheses, hit set point 1 and then hit enter. It's gonna be 3.7855. Now you need to find the residual. So residual is gonna be actual value subtract the predicted value. So actual value is gonna be 3.7, right? Subtract 3.7855, right? So it's gonna be negative 0.0855, right? Which is less than 0. So then the model overestimated the actual values, right? Now we can use the TI-84 plus CX calculator to do this. Alright, I'm gonna hit start, edit, and hit enter. Now I need to input values for the first and the second columns, which is L1 and L2, right? Alright, next I'm going to hit start, go to count number 5, quadratic regression, hit enter. Now I need to store equation right here. I need to hit fast, y fast, function y1, hit calculate, and this is my answer for the quadratic regression, right? So it's gonna be similar to this one, right? Alright, now I just hit graph, it's gonna be right here. Alright, so I want to see the whole thing, I just adjust the window, right? And hit graph, it's gonna be right here, right? Now we need to predict the y value when s equals 6.1, right? So you just hit second trace, number 1 right here, values. Alright, so you just hit 6.1, hit enter, it's gonna be 3.7855 right here, right? And it's good time to stop.